Så där, nu är klockan ganska prick 9:30. Så att vi ger det 15 sekunder till och sen så kör vi igång, tänkte jag. Ja, hej och välkomna till VCI Valves och dagens webinar om grundläggande om tankskyddsutrustning. Jag som sitter här heter Christer Lundgren och har jobbat på VCI i ungefär 10 år och sysslar både med produktion och försäljning av våra ventiler och reglerventiler. Som ni förstår när jag säger produktion så har vi en egen tillverkning av reglerventiler. Men vi har också ett stort brett sortiment kan man säga utav agenturprodukter. Och i en av de agenturprodukterna som då representerar och säljer i Sverige och även i Norden så har vi Cashco. Cashco är ett företag som ligger i Kansas i USA och har funnits på marknaden ungefär i 100 år. Vi på VCI har representerat dem ungefär i 40 år. Så att det finns en lång och trogen utbyte av teknik och försäljning och tänk runt tryckregulatorer men även då på sånt som ingår i dagens webinar. Då har vi valt att titta närmare på deras del. De har förutom det vi ska prata om har de även regulatorer och sånt. Vi ska titta på flamskydd, tankinertering, tryck- och vakuum-ventiler och tryckavlastningsventiler. Det är det som ni ser på agendan också. Vi kommer att prata grundläggande. Vi kommer att titta på komponenterna som ingår i konceptet. En del om dimensionering och urval. Det finns lite beräkningsprogram som man kan ladda ner själv och hantera. Det finns egentligen vilka vanliga industrier och applikationer man kan stöta på. Sen på slutet av webbinariet så kommer vi även ha tid för frågor. Och de frågorna kommer gå att ställa både på svenska och på engelska och vi försöker svara på dem i chatten. Eller så kommer vi, när det här är slut så kommer ni få ett tack-mail där det finns alla våra kontaktuppgifter. Till min hjälp då idag så kommer jag ha Kevin Wheeldon som är en representant för Cashco som sitter i England. Så han kommer att hålla webbinariet på engelska. Så hoppas att det kommer gå bra. Så har ni frågor under resans gång, ställ dem i chatten så försöker jag kommentera eller hjälpa till. Så, det var vad jag hade att säga så att vi hörs efter att Kevin har kört sin presentation. So Kevin, the stage is yours and good luck. Thank you.
Thank you, Krista. Good morning, everybody. Thank you for joining us. Appreciate you taking the time out, giving us the opportunity to introduce you to Cashco. I'm just going to share my screen and start the presentation. So Krista already mentioned, I believe, that any questions can be written in the chat, and at the end of the presentation I'll be happy to try and answer those, or if you've got anything you'd prefer to email us directly or look back on the presentation, then please just let us know. Okay, so who are Cashco? Well, we're headquartered in Kansas in the US. We've been in corporation for, well, we started in 1920, so just over 100 years. Unfortunately, our 100-year anniversary coincided with nobody being able to visit the factory. So we've not been able to celebrate properly yet, but that's the intention. So from the US, we have a turnover of, well, over $20 million now with the products that we manufacture from there. Reaching a global audience through our network of representatives. We have regional sales managers who sit strategically located around the globe and work with companies such as Ramen in Sweden to offer our products to customers in country. We employ over 150 people. I think we're the biggest employer in the village or town of Ellsworth where we reside. It's a nice facility. As you can probably tell from the picture, it's recently been refurbished. This is a new office building, a lot of investment in machinery going in. We also have a operation in Europe. So this is based just outside of Berlin in a place called Hoppegarten. This was originally set up to manufacture our flame arresters, which form part of the vapor recovery products that we're going to be talking about today. The intention is to have more products manufactured and assembled from Germany, which will give us a better strategic position for selling into Europe in terms of logistically and delivery times and so on. So yeah, 2 facilities mainly across the world. On the video is that from the US facility, we're manufacturing control valves, linear and rotary control valves, and industrial regulators. The product range that we're going to focus on today is the vapor control systems, which involves tank blanketing, pressure vacuum relief vents, emergency vents, gauge hatches and flame arresters. Essentially, that's all our products that are associated with tank storage, controlling emissions, protecting the tank. Vapor control systems, unfortunately, I had another video. Hopefully this works. I'll stop it after a few seconds and you can let me know if you can hear it, or I can narrate over it. You hear that?
No, sorry, it's no sound.
Yeah. Okay, no problem. I can talk over it. So the intention of the video was to show you the equipment in situ on a storage tank. So going left to right, we've got the tank blanketing valve, emergency manway in the middle, and on the right hand side, a pressure and vacuum relief valve. The idea of this equipment is to work together to protect the storage tank. As most of you know, there's liquid stored in the storage tank with a vapor space above that. Changes in temperature can increase the pressure or decrease the pressure in a storage tank. So throughout the day, if the product's heated through the sun, that increase in pressure will build to the point where you've got your breather valve set point. This will allow the vapors inside that tank to breathe, obviously helping to protect the tank from any form of overpressure. Also, when you fill in the tank, that vapor space will decrease, that pressure will increase, and it needs to escape. So essentially, that's the role of a pressure and vacuum. You'll see the vacuum side of it working now. As you're emptying the tank, or as the tank cools overnight, that pressure will drop. On this tank, we have a nitrogen blanketing valve. So as the pressure drops in this tank, what would normally happen is it would draw in air through the vacuum side of the valve. Some tanks are fitted with nitrogen blanketing valves, which is at this point that would push nitrogen into the vapor space of the tank. There's various reasons why you would want to use a nitrogen blanketing valve rather than just bringing air into the tank, and we can touch on those later. You can see that if there is no nitrogen there with the cross, that the pallet on the vacuum side of the valve would lift and allow air in. The emergency vent is essentially just that, for emergencies. So if you had a fire around this storage tank and the product was heated up quickly, the vapors that are created are much greater than what can be handled by the standard pressure relief valve. That emergency manway flips open, allows the excess pressure to escape, and it's only there to prevent that tank from overpressurizing and essentially exploding. And we touch on the products in more detail further into the presentation. So what is a vapor control system? As I touched on, it's an arrangement of equipment that help to protect the tank and reduce and control vapor emissions. So why do we need pressure and vacuum protection? Well, as we said on the video, they help the tank to essentially breathe during filling and emptying. As the temperature increases or decreases through the day, that pressure will do the same. That's called thermal expansion, and the valve operates to help protect against that. Most storage tanks are designed for very low vacuum pressures. I've taken the picture from another slide that I use. Essentially, just trying to show that a can of Coke is designed for pressure. You've got fizzy drink inside there, but it's not designed for vacuum. Very easily to crush. Similarly with a storage tank, they're generally designed to hold pressure. They're not designed for vacuum, and that can be what drives sizing and specification of a product, the vacuum requirements. Pipe away vents, as with the two units on the right hand side, what these are essentially doing is collecting the vapours that are being vented from the tank. Again, you might want to do that for various reasons. It might want to be toxic, it might just be to conserve the product. We have vapour recovery units where we're trying to capture that vapour, turn it back into fuel. Obviously, all that helps to reduce emissions. How does the valve work? Quite a simplistic device. On the left-hand side, you've got your pressure pallet that's sat on a stainless steel seat. That pressure pallet contains a diaphragm and backing plate. And we've designed that to try and be as tightly closed as possible up to the set point. ISO sets out some standards for that, which we'll talk about on the next slide. Most of the valves we sell into this application are what's called weight loaded. So on top of the pallet, you've got either stainless steel or lead weights, which create the set point. Similarly, on the vacuum, on the right hand side, similar design, weight loaded in this case, and both operate as you saw in the video. As the pressure increases, the pallet on the left hand side will lift. Similarly, on the right hand side, as you've got the vacuum. So API 2000 is generally the standard that we adopt for atmospheric storage tanks and sizing of and requirements of valves for those. That's changed over the years. As you can see on the left hand side, the first edition was in 1952. Right now we're on the 7th edition that's been reaffirmed. Not many changes since 2014, other than the introduction of different annexes at the back. We also have a European standard now, which is ISO 28300. So in 2009, 2008, those were brought together, and they're actually identical documents now. So in Europe, we would adopt ISO 28300. Yeah, as I mentioned, it goes through all the different requirements for atmospheric storage tanks and covers nitrogen blanketing tanks as well on the back pages of that. It's quite a useful document if you're involved in tank storage. Not the easiest of reads, but good information. So still on normal venting, the image on the left-hand side is taken from our online web sizing program. That's accessible to everybody via the website. It's a really useful, powerful tool that allows you to go on and just do primary sizing specification of a valve. Obviously, we'd be happy for you to and expect you to come to us or Raman as the experts and run through this or confirm your thoughts. But if you're just looking to check, is my valve suitable? Do I have the right flow rates? It's a good tool. When you're completing this, there's minimum information that we need for sizing a valve. The first thing is the design pressure of the tank. Obviously, you can understand why. We're trying to size a valve here that will protect that tank. So we need to know what it's been designed to for. Looking at the tank volume, or if that's not known, you can actually put in the tank dimensions and it will calculate the volume for you. That's essential when we're looking to calculate how much vapor or air we need to expel. The flash point or boiling point of the media is also important with the calculation. When we're looking at the pumping in and pumping out rates, we need to know if that product is going to flash at all. So essentially, those are the 5 criteria for sizing a pressure vacuum relief valve. The rest we can work around and work with you. This is quite an old slide now, but I think it's still quite relevant. Most tanks do have pressure vacuum relief valves on them now, but not all of them. API did a calculation to show that a 55,000 barrel capacity tank would vent 2,000 barrels per year if it just had a standard open vent on it. By installing a pressure vacuum relief valve, that was reduced to 1,382, which might not seem significant, but you're actually saving over 600 barrels a year by fitting a PRV. When you think that the average oil price last year was $55, the total yearly saving just on those 600 barrels is $34,000. So essentially a pressure vacuum relief valve can pay for itself in less than a month. So what is tank blanketing? This is a really well animated and narrated video. Unfortunately, you can't hear it, but I'll play it and I'll talk through it. So this is our model 1078 tank blanketing valve. How it operates, as we said, is to inert either nitrogen. It doesn't have to be nitrogen, whatever gas you wish to use to create a blanket on top of the vapor. It's a very simple design, very reliable. You'll find that in Europe, I believe this to be the best blanketing valve on the market due to its accuracy and reliability. How it works is you can see that traveling, what's that is, it's the pressure traveling up the sensing line, we call it. That's sensing the pressure inside the tank. Some regulators actually sense the pressure in the body of the regulator, and you're not getting as much accuracy at that point. So this sensing unit goes right into the header of the tank. As that pressure decreases, the pressure underneath the pallet in the pilot also decreases. That creates the spring to open the valve and therefore push nitrogen into the top of that tank. Obviously, as that pressure then will increase due to the nitrogen, the sensing line will sense that increase in pressure and it will shut the valve off. They're highly accurate pieces of equipment. Very, very easy to maintain. As I said, they can actually be done in situ. You can calibrate them in situ as well on top of the storage tank. So we'll look a little bit more at the product itself. So why do you fit nitrogen blanketing? Well, you're keeping air and moisture out of the tank. So one of the customers we use produces sugar, where you don't want any moisture mixing with the sugar. So they will then push nitrogen into the vapor space to take away that moisture. You can dilute the oxygen content of the vapor space below its flammable ranges. So you're making it inert. Obviously, that's good if you're dealing with flammable products. You can also enrich that vapor space and take it above its flammable range if you want to maybe push in a flammable gas, whatever you're using. So you can use it in both ways. Dilute toxic vapors for safer emission levels. Obviously, everyone's talking about the environment now. There's a big push on valve leakage globally. So this is becoming a very, very popular product for us and for you as a customer to use. Also helps to prevent internal tank corrosion. If you've not got air in there and moisture, obviously you've not got that possibility for corrosion. And as I said, the requirement for tank blanketing can be found in the ISO 28300 standard, Annex F, which is informative standard. It gives the guidance on how you use tank blanketing, what the requirements are, what extra protection is required. Again, we don't expect you to go away and understand and read all that. That's just the standards that we adopt as a manufacturer for specifying. So important factors to consider when you fitted nitrogen blanketing. The first one is that it's got to exceed the breathing requirements. So when you're pumping out of that tank, we calculate the breathing requirements, and the amount of nitrogen that valve lets in has got to exceed the in-breathing requirements before you allow air into the tank. Otherwise, it's mitigating everything you're trying to achieve. And it must do that at the minimum nitrogen supply pressure. So if you came on for a nitrogen blanketing valve, we'd be asking you what your supply pressure is. The valve must also shut off and be bubble tight before reaching the relief valve set pressure. As I mentioned right at the beginning, we're looking at a control system. We need to know how they operate with each other. If they're not bubble tight, you could get leaks on the valve itself. So we have two models for this. On the left-hand side is our model 1078. As I've touched on throughout the world, it's known as effectively the best regulator on the market. Unrivaled accuracy, very easy to maintain. Our valve is bubble tight at shut off. Some manufacturers go above shut off. They have a closing pressure. We don't. What we say it shuts at is bubble tight. For smaller batch tanks, we use our model 1088 on the right hand side. Bit more lightweight, easier to access. The capacity is obviously reduced in that unit, which is why it's for smaller tanks. So moving on swiftly, we're looking at pilot operated vents. So if you were looking at more accuracy than your standard pressure and vacuum relief valve, this is the unit you'd be looking for. So using pilot operated technology, it's the most precise way to achieve your set point. So with a weight loaded valve, once it reaches set point, the pressure will increase. You have an overpressure to achieve the flow. With a pilot operated valve, you don't have any overpressure. As soon as this hits set point, it opens fully and you get full flow through the valve. The way it operates as well, you'll see now this sensing line that actually puts pressure above the diaphragm where the seat is and below the diaphragm on the pilot. What that helps to achieve is as that pressure increases, pressure on the seat in the valve, as you'll see now, also increases. So actually, as it gets closer to set pressure, it becomes tighter. So you get no leakage through these pilot operated valves. So if you are using a particular product that you really don't want to escape, you don't want to vent before set pressure, pilot operated technology is the way to go. Also, if you're looking for full flow very quickly, such as LNG tanks, where they're offloading at high speed, this is the unit to go for. As soon as it hits set pressure, you get full flow, full lift. So as we've said, what do pilot valves offer you? You've got tight seat leakage or no seat leakage, full flow with less overpressure. You're generally looking anything up to 10%. You don't even need 10% to be achieving full flow. And they're not affected by back pressure. So on the full blue units, the model 5200 and 5500, where they're piped away, if you add a back pressure in your system, these would not be affected by that. Whereas with a weight loaded unit, that's something you've got to consider. So these have zero leakage, up to 99% of set point. API actually allows for up to 5 standard cubic feet per hour at 75% set point for weight loaded. So you can see the difference. At 75% of set pressure, a weight loaded valve, and that's anybody's, is allowed to leak up to 5 standard cubic feet. So 80, 90, it's leaking even more. It's essentially working, it's operating. Pilot valve doesn't do that. At 99% of set point, it's totally closed. Full flow at 10% overpressure, as I mentioned. The weight loaded vent, generally looking to start at 20%, but up to 100% overpressure at set point. To put that into figures for you, if you set your valve at 10 millibar, you would be looking at a minimum of 12 millibar to get your flow up to maybe 20 millibar. And not affected by back pressure, as we said, especially useful on header systems. Emergency venting. So why is emergency venting required? As we talked about at the beginning, generally for fire engulfment of storage tanks. So these are much bigger openings. These allow for much greater flow in case of fire conditions, quickly heating up the products in the tank and creating a lot of vapor. We do different arrangements of these, from standard weight loaded on the left hand side. We operate spring as well if you've got higher pressures, and we can also add additional vacuum capacity to this unit, which again, when we're looking at full vapor control systems, you know, that offers us some good advantages if you've got high vacuum requirements. What I would say at this point is, if you are looking to specify or size tank storage equipment, it's essential really that you go to the manufacturer with all the equipment and size it as one. It should really be looked at as a complete system, whoever you're working with, because they do conflict with each other, these pieces of equipment, especially if they're not specified correctly. Another nice video. We don't actually need the sound for this one. So here you've got a fire engulfment scenario. What's happened is the vapor is trying to escape from this storage tank under high pressure. That's through a normal relief vent. It's ignited because of the fire in the surrounding area. What we'd like to see now is an emergency vent open and let the pressure escape from that storage tank. This tank doesn't have an emergency manway fitted, so the pressure is building and building. And essentially, if the pressure's got nowhere to go, it's going to lift the storage tank with catastrophic event. Moving on to just some of the sort of tank furniture, tank fittings that we also manufacture. We've got relief vent gauge hatches. These allow you to access the tank for dipping, sampling, and also just on the top left hand side, that's our emergency manway in a GRP model. We do plastics, we can do HALAR. We have various options for those, again, if your product is particularly corrosive. Moving on swiftly, we're going to look at flame arresters. So flame arresters are static devices that sit within pipelines or vent pipes and stop any potential flame from travelling down back into the supply area and creating a much bigger event. So I mentioned that the static flame arresters, the way that they operate is through this crimped element, which has channels going through it. Essentially, stripping the heat out of the flame. Now, as a manufacturer, we measure the gap width, known as the MESG, of that crimp. That allows us to specify the flame arrestor depending upon what gas you're going to be using. Quite a quick video, quite a difficult subject to take in if you've never dealt with flame arresters. Essentially, they're allowing gas to flow, but should that gas become ignited, they're stopping the flame travelling back. I hope that sort of covers it. As you can see in the top left hand side, these arresters are suitable for 2A1, 2A, 2B1 and so on gases. The way that works is each gas is categorized into an explosion group, sometimes messed up with dust groups or zones. It's not that. This is a flame arrestor gas explosion group. What we do is we measure those crimps, we test to that group, and that's what gives us our ATEX certification. So if you come on as a customer and say, I'm using propane, we know that's gas group 2A, we will specify a flame arrestor suitable for that gas. It's important that you have the specification correct, not just so it stops the flame, because if you don't do that, it won't, but also as the gas gets more volatile, the element gets more restrictive. So we like to give you the best performing unit as we can. The model on the right hand side is what we call an end of line flame arrestor. So this is what you would see on storage tank most commonly. And it's allowing the vapors to escape from the tank. But should they become ignited through lightning or some ignition source on top of the tank, it would stop that flame entering the vapor space of the tank and creating an explosion. Two different types. On the left hand side we have deflagration, and on the right hand side we have detonation. If you wish to know more about these products, this is my background, so I can talk about these for all day. Essentially, it's where they're situated to the ignition source. So a deflagration arrestor, you have to fit close to any potential ignition. If there was a flame, it would stop that deflagration flame. If you can't do that because of access or pipe work or something, you need to fit the flame arrestor a long way from where the ignition could happen, then you would move to a detonation arrestor. As I mentioned before, it's the crimp, the technology in the middle of these is what's doing the work, and you can see on the detonation unit that's much more substantial. So we like to offer a deflagration, that's the intention, but if not, we do have a detonation unit that would also work. So where will you see flame arrestors? This is an offshore platform. Any vent offshore will have a flame arrestor on them. Obviously, as I said, to stop any more catastrophic events if you're venting those gases. On storage tanks, you may see a flame arrestor through the PV valve. If you're looking to capture those vapors, as we spoke about in a vapor recovery unit, there would be a detonation flame arrestor there, because essentially the ignition source would be the vapor recovery unit, and that could be 50 meters away, down your terminal. Flare systems all have flame arrestors installed on the gas supply line. Should you get a backfire or the ignition going back towards the gas supply, that flame arrestor is your protection device to stop it traveling back further down the gas line. And find, well, there's lots of applications. This is a blower or fan. If customers need to ATEX rate their fans even for flammable atmospheres, they would fit our flame arrestors, and they actually go away and do secondary tests, and then that fan would be classed as ATEX rated fan. And we work with manufacturers, with OEMs, to help supply the best technology and sizing and so on for these applications. So just to summarise on Cashco, as you saw at the beginning, extensive manufacturing experience from the US and also now in Germany. All our equipment is API certified. We follow those standards when we're checking the leak rates, flow paths and so on. Web-based sizing programs available based on API 2000. We have localized aftermarket support. Raman are actually our first company in Europe to be accredited as a Cashco repair centre. So yeah, if you've got any issues with your valves, regulators, then we can work together with Raman to hopefully, fix those more locally for you guys. Documentation, obviously, documentation is a big part of everything we do. Functional test reports, calibration, certs, and so on. Wide installed base. We may have worked with some of the companies you represent globally. As I say, we've been operating for over 100 years, so we've got some wide installed base of our products. And that's me. Thank you, Krista.
Thank you very much, Kevin. Very well performed, and you are an excellent narrator of videos now. Så det var, ja, thank you. Så det var vad vi hade att erbjuda vad det gäller det här webbinariet om grundläggande tankskyddsutrustning, och ja, som Kevin nämnde, det finns en lång historia. Kevin är mycket erfaren på kanske framförallt tankskydd generellt, men även på tryckregulatorer och annat som Cashco tillverkar. Ja, har ni frågor eller annat så ställ gärna dem i chatten, så försöker vi svara på dem på engelska eller på svenska. Som jag nämnde innan så kommer ni få ett uppföljningsmail skickat till er med alla kontaktuppgifter som kan behövas om ni vill skicka en fråga eller något annat. Vi ger några minuter och ser om ni har några frågor. Kan det vara så att allting var helt klart också. We see what happens, Kevin, or else you have done a great job and everybody is really glass clear with.
Or everyone's gone for a coffee.
Yeah, exactly. Okej, det ser inte ut som att ni har några frågor just nu, så att då tackar jag för ert deltagande och på återseende och återhörande. Thank you, Kevin. Hej då allihopa.